Hello and welcome to the Graphing Exponential Functions video. Please take a look at page number 6 from the 4.3 notes. I'm just going to be going through all these graphs and I'm hoping they're going to be pretty quick because this is very much related to Unit 2. If we were to draw or write out kind of like the general function for an exponential function, it's going to look something like this. Y is equal to A times 2. We're always going to be using a base of 2. Power of b times x minus h plus k. And I take a look at this and I go, oh, a, b, h, and k, I recognize all of these letters. These are from our transformation unit. So just a quick reminder, b is our horizontal compression or stretch, h is our horizontal shift, left or right, a is our vertical compression or stretch, and k is our vertical shift either up or down. If b is negative, then you're reflecting over the y-axis. If a is negative, then you're reflecting over the x-axis. So this is all the same type of information. Now we're just applying it to a brand new function, a brand new parent function. So let's get started. Like I said, our base is always going to be 2 to the power of x. Figure 4 is just going through and graphing the parent function. So let's focus in on that. So let's see, first thing I'm going to do is I'm going to make a table for 2 to the x. We're going to make this -2, -1, 0, 1, and 2. So let's see, the parent function here, if I take 2 and plug it in to our function, so 2 to the power of 2, we're going to get 4. If I take 1, plug it in, we're going to get 2. 2 to the power of 0, or anything to the power of 0, as we know, is just 1. 2 to the power of -1 becomes 1 over 2, wherever you change that into a fraction. And then 2 to the power of -2, that's going to become, 1/4. So if I was to graph this, this would look something like, I'm going to start just plotting the points. Let's see, that slid. This would go over here. Half, a fourth. And when we connect our points, we're going to notice that we're going to get really close to 0, but it's never going to be quite equal to 0, also known as an asymptote. So an exponential function is a function that's going to have an asymptote. No vertical asymptotes, but it is going to have a horizontal asymptote. In this case, it's going to have a horizontal asymptote. I'll write that over here. At y is equal to 0. So the last piece here I want from you is I want you to write down the long run behavior. So the long run behavior for us is as x goes to -infinity, f of x goes to 0. So we can see right here that as our x values become more negative, the y value gets really close to 0, but not quite. And then as x goes to positive infinity, f of x goes to also positive infinity because it's going up. As our x values are getting bigger, our y values are also getting bigger. So in this case, we are no longer having our y values either both go to some type of infinity or just the horizontal asymptote. Now we're mixing the two. So this is what the parent function looks like. The other 5 graphs are just going to go through some of these shorter transformations. So for each of these, I'm going to do a table for each one, the horizontal asymptote, graph it, and the long run behavior. So let's get started. So number 5 is 2 to the x plus 1, which means we're going to be moving up 1. That's a vertical shift up 1. So if we draw our table, it's going to be the same table every single time. So I'm going to go through these kind of quick. Since this affects our y values, I'm going to add 1 to all of our y values. So you can do this in either a mixed number, improper fraction, whatever you want to do. Do 5, 3, 2, 1 1/2, 1 1/4. when I graph all of these points, it's going to look something like this. And just how we used to have a horizontal asymptote when y was equal to 0, now since it's been moved up 1, we're now going to have a horizontal asymptote right here. I'll actually write this over here. When y is equal to 1. So when we graph our graph, it's going to look very similar to our parent function, except it's been moved up 1, which means that for our long run behavior, which I'm going to shorten to LRB, as x goes to negative infinity, f of x is going to go to 1 instead of 0, since that's our new horizontal asymptote. And then as x goes to positive infinity, f of x is still going to go to positive infinity, because now it's moving upward. So the more we practice, hopefully the faster these will go. Let's try another. So figure 6, whoops. So figure 6 over here, let's zoom in. Let's see, this will be the same parent table. Oop, that's still in blue. All right. Same parent table. Now, when we take a look at this, we now have an a value out in front, and I'm going to highlight that. We have an a value out in front right there, and that a value is a vertical stretch. So we're going to take all of our y values and multiply them by 3. So our y values are 1/4, 1/2, 0, 2, and 4. And we're going to take all of these values, and I think we did these in green. We're going to multiply them by 3. So they're going to become 3/4, 3/2, or 1 1/2. I just noticed a mistake in my table. When the x value is 0, the y value should be 1. And when we multiply that by 3, that'll be 3, and then 6, and then 12. There we go. So we're going to be using this x value and this y value as we go. We're not going to be able to plot all of these points. For instance, we can't fit 12 on there. We can't even fit 6 on there. So when we graph, it's going to look like, let's see, 1, 3, pardon me, 0, 3, excuse me, negative 1, 1 and 1/2, negative 2, 3/4, right here, and that's going to look just very stretched out version what we have, and that's still going to get really close to 0, but not quite, meaning that we still have a horizontal asymptote at y is equal to 0, and our long run behavior is going to be the same as the previous function above. So as x goes to negative infinity, f of x goes to 0, and as x goes to positive infinity, f of x is also going to go to positive infinity. Let's try the next question. So over here, we also have something in front dealing with our a value, but now it's negative, which means that we are going to have a reflection over the x-axis. So when we make our table, again, this is going to be the same table that we've been using. So the x values of negative 2, negative 1, 0, 1, and 2, and the y values, I'm going to get it right this time, I promise, of 1/4, 1/2, 1, 2, and 4. We're going to take all of those y values and multiply them by a negative 1. We get negative 1/4, negative 1/2, negative 1, negative 2, and negative 4. So when we plot all of our points, we're going to be using these x values and these y values. So negative 2, negative 1/4, negative 1, negative 1/2, 0, negative 1, 1, negative 2, and 2, negative 4. So it looks something like this. So very similar to original graph, just reflected over the x-axis. And we're still going to have that asymptote right here at y is equal to 0. And our long run behavior is going to be as x goes to negative infinity, f of x goes to 0. As x goes to infinity, now f of x goes to negative infinity, since that right arrow is now pointed downward. So now that's going to go to negative infinity. Let's do just 2 more graphs. Oops, I keep doing that. So for figure 8, over here we have a negative again, but now it's our b value. That's negative, that's going to be right there, which means instead of reflecting over the x-axis, we're not going to be reflecting over the y-axis. So when we create our table, x and y, -2, -1, 0, 1, and 2, with our y values of 1/4, 1/2, 1, 2, and 4, we are now going to be multiplying our x values by -1. So we get 2, 1, 0, -1, and -2. We'll be using our new x values and our original y values so that we have 2, 1/4, 1, 1/2, 0, 1 is going to stay the same, -1, 2, and -2, 4. So again, it looks just like our original graph, just reflected. Whoop. We're still going to have that horizontal asymptote at y is equal to 0. And then lastly, for our long run behavior, where's my paper? There it is. For a long run behavior, it's going to be switched so from our original. So as x goes to negative infinity, f of x goes to positive infinity, because we can see that as our x values are going more negative, our y values are going up. And as x goes to positive infinity, f of x goes to 0. Because now as our x values are growing larger, our y values are getting really close to that asymptote, but not quite reaching it. So I just kind of wanted to move through a few different examples of transformations with you. You'll be doing some more in the Go Formative, but for right now, let's take a look at if we mix 2 of these together in figure 9. So in figure 9, we have 2 things going on, and you may be a little bit more familiar if we rewrote this as -2 to the power of x plus 1. So we have 2 things going on here, both with our y values. So we're going to be multiplying our y values by -1, or reflecting over the x-axis, and then moving our graph up 1. So let's make our table. Oops, that is still a highlighter. Let's make our table -2, -1, 0, 1, and 2, 1/4, 1/2, 1, 2, 4. And we're going to be doing multiple things to these y values. So it is important to reflect before you shift, because multiplication comes before addition. So first we're going to multiply everything by -1, and then we're going to add 1 to everything. So this will be -1/4, -1/2, -1, -2, -4. And then we'll add 1 to everything. So it becomes -3, -1, 0, +1/2, and +3/4. So using our original x values and our new y values, our graph is going to look something like this. Let's see, -1, 1/2, and then we have 3/4 up here. Oh, that's still in green. Whoops. Not going to switch it now. Okay. It'll look something like this, and we're getting really close to 1, but not quite reaching it. And that is because our horizontal asymptote moved up 1 as our whole function got moved up 1. So now we have a horizontal asymptote at y is equal to 0. So our long run behavior here is going to be x goes to negative infinity, f of x goes to 1, since that is our new asymptote, horizontal asymptote. And as x goes to positive infinity, f of x goes to negative infinity. So this is a lot of the same information that we use from our transformations unit in Unit 2, just with a new parent table. So make sure you keep practicing this. The only other things I'll ask you in the Go Formative or about domain and range, we will go over those in class, but if you have extra questions, please let me know. Good luck on that Go Formative.